Number 34, the mean value theorem, which is number 3 of our big 5 theorems. Here we go. So the mean value theorem states that if a function is continuous, that is super important. If it is continuous, it must be continuous. And if it is on a closed interval from A to B, so we're going to say that this is A and that this is B, okay? So closed interval A to B, if it is continuous and if it is differentiable. So we've got two conditions. We've got 1, continuous, 2, differentiable. If both of those things happen, then we can look and see and say that the mean value theorem is happening. Here's what the mean value theorem says. The mean value theorem states that on a given interval from A to B, there is some point, which we will find, where the slope of the tangent line, so I'm going to just pick this point here, is equal to the slope of the secant line. Sorry, this is hard to draw straight. Not perfect, but you get the point. Okay, so we want the tangent line is equal to the secant line. So this is the tangent line. Remember, tangent touches at 1 point, secant touches at 2 points. Okay, so the mean value theorem says that for every single graph that is continuous and differentiable on a closed interval, there's got to be at least 1 point where the tangent line equals the secant line. Our tangent line and our secant line are both rates of change. We remember which one's which. This one is my IROC, my instant rate of change. And this is my AROC, right? So it's saying that somewhere my IROC has to equal my AROC, okay? And we know formulas for IROC and AROC. So let's think about what those formulas are. AROC, trying to flip here. AROC, remember, is F of B minus F of A all over B minus A. So this is my AROC. Is equal to my IROC, and we know that IROC, the instant rate of change, is the same as the derivative. So essentially what the mean value theorem is asking me to do is to find where the average rate of change, slope of the secant line, is equal to the IROC, or the derivative. Okay, so that's what this note card says, this handy, fancy note card that a brilliant woman made for us that we are so lucky to get to use. So see, there it is, right? It says that the instant is equal to the average. So I'm going to add that to my notes. You add it to yours. It's where IROC equals AROC. And you shouldn't have to memorize anything because this should already be in your brain as AROC, right? Your instant equals your average. And then here it also says where your tangent line is parallel to the secant line, or the slopes are the same, right? Parallel means slopes are the same. Slopes are same. Okay. All right, so let's look at number 1. It says, let f be the function given by that. Find the number c that satisfies the conclusion of the mean value theorem for f on 1 to 3. Okay, so we want my IROC equals my AROC. My IROC is my derivative, so let's take the derivative. I'll do it on here. So we want my IROC, my derivative, so we're starting with this, which is f of x equals x cubed minus 7x plus 6. So I want my IROC, my f of x, so that is 3x squared minus 7, okay? And then I want it at, and I want to find c, okay? So I want, actually instead of f prime of x, I want f prime of c, and I'm going to try to find c, right? So I have 3 c squared minus 7. Okay, now I want to find the AROC. So this is my IROC. I want to set that equal to my AROC. So that AROC, and remember I'm working on the interval from 1 to 3. So this is my A, this is my B. Okay, so AROC is f of B minus f of A. So I'm going to have to find those first over B minus A. So we want f of B, so f of 3, so plug that in. F of 3, we would have 3 times 3 times 3 is 27 minus 21 plus 6. So that would be 6 plus 6, so that's 12. So I would have 12 minus, and then f of 1, right, because A is 1. So I'd have 1 minus 7 plus 6. That would be 0. So I have 12 minus 0 over b minus a, 3 minus 1. So I have 12 divided by 2, which is 6. Okay. So now I want to set this equal to this, my I rock equal to my a rock. Okay. So I have 3c squared minus 7 equals 6. So I'm going to add 7 to both sides. I get 3c squared equals 13. C squared equals 13 over 3. And yes, it looks weird, but it's okay. Take the square root, and I would get, running out of space here, c equals plus or minus, technically, because anytime we take the square root, okay, but compare that to our interval, right? Our interval said only between 1 and 3, so we only want the positive version. So actually my c would just be this here. So that is the value of c based on our mean value theorem, based on setting our a rock equal to our I rock. Let's do number 2, which is a calculator question. So we've got f of x equals x plus ln of x, but I can take the derivative of that without a calculator because I know that the derivative of x is 1 and the derivative of ln of x is 1 over x. Okay, so I want that to be equal to f of b, which is 4, minus f of a, which is 1, all over 4 minus 1. This is why I need the calculator, so let's do f of 4. So I am going to do 4 plus the ln of 4, 5.386, minus, and then I want 1 plus the ln of 1. Those of you that don't know where the ln button is, it is right here. There we go. And I get 1. All over 4 minus 1 is 3. So I would get, that would be 4.386, right? 4.386 divided by 3 equals 1.462. So I want my a rock is 1.462. I want that to be equal to my derivative that was up here. 1 plus 1 over x. So I can subtract 1 and get 0.462 equals 1 over x. Multiply by x and then divide by 0.462, right? Because I would get 0.462 x equals 1. So then divide by 0.462 on both sides. And then 1 divided by 0.462, putting that in the calculator, except I just did minus, don't do what I do. 1 divided by 0.462, except do, because catch yourself when you do that, is 2.165, rounding up. 3 decimals, because a calc. There you go. That is our answer. Probably should have gone over why I did that. I just kind of jumped into it. Okay. Oh, and I skipped something important. Let f be the function defined by what is the value of c for which the instant rate of change is the same as the average, right? So that's asking for mean value theorem. What I skipped is our conditions. We should have checked first to make sure that it's continuous and that it's differentiable, right? Over 1 to 4. Okay, I know that x is fine. X, I can put in anything for x, right? That's not going to give me problems. ln of x, I can only plug in positive numbers. But because my interval is only positive, then I know that that's fine. So this is continuous and it is differentiable. So when you're answering, you should put that in your answer. F of x is continuous and differentiable. So by the mean value theorem, there exists a C where I rock equals a rock at C equals, and we found it was 2.165. Beautiful. All right, last question. Here we go. Let f be a function that is differentiable and also the second derivative is greater than 0. Okay? Using the chart below, find a positive number r having the property that there must exist a value c with this interval and f double prime of c equals r. Give a reason. Okay, so this is a lot of gobbledygook. what we need to do first is, I know that this is MVT because it's asking for a value C within an interval where a derivative equals a number. Okay, when you see that, you know that it's MVT. Okay, so first for MVT, we have to check that this is continuous and differentiable before I can use the MVT. It clearly states here that f is differentiable, okay? But it doesn't say it's continuous. We know, though, that if something is continuous or differentiable, it has to be continuous, right? If it's not continuous, it's immediately not differentiable. So we know that because f of x is differentiable, it must, be continuous. Therefore, by MVT, there exists a C where f double prime of C equals R at C equals, we need to find it. Okay, so let's start looking. We want our instant to be equal to our average, right? So I'm going to leave that there so we can see it. And we want instant equal to average. Okay, so I want f prime of C, f double prime of C, that's really important, okay? So now, average rate of change, we want to go up one level. So normally if we have f prime of C, we would use f of B minus f of A. We have double prime, so we only want to go up one level. So here we want f prime of B minus f prime of A, and it's still over B minus A. So now let's use our chart and our interval. So our interval is from 0 to 0.5, so B is going to be 0.5, and A is going to be 0. B is 0.5, A is 0. So f prime of 0.5. So f prime, so I want to look in this column here, the second column, or sorry, second row. This column, f prime of 0.5 is 3, so I have 3 minus, and then f prime of 0 is 0 over 0.5. 3 divided by half, there's 6 halves, right? 6. So we've got that it equals to 6, so this must be our R. Okay, and actually we're going to read the question carefully because I made a little mistake here in our writing out here. We wanted to find a positive number R, so it's asking us for R, not for C. So this should actually say at R equals, and our R was 6. There you go. There is our full answer. So make sure that in your answer you're including your conditions, that it's differential and it's continuous. We state that by MVT, that needs to be in there. There exists a, sorry, this should say R. This is why we read the problem carefully, people. An R where f double prime of C equals R at R equals 6 using our table. There you go. Until next time.